Hey, welcome back to the lecture. So from this lecture onwards, let's learn about functions in C. Let's learn how to write functions, what is a function prototype, and how to call function, and we'll understand various other things related to functions. So in C, you write executable statements inside a function. For example, so here, let's say in this program, so I cannot cut this code and I can't put this code here. This is actually an executable C statement, right? So we cannot keep this outside the function. So this is illegal in C. So it has to be inside a function. So all the codes that is executable statements must be inside the body of the function. Of course, you can do a variable definition outside the scope of a function, no problem. So even you can initialize that variable. So this is nothing but variable initialization. So that you can do outside the scope of a function. But the executable statements has to be inside the function. So in C, a C function is nothing but collection of statements to perform a specific task. So every C program at least has one function called main. So using functions bring modularity to your code. It is easy to debug, modify, and increases the maintainability of the code. Using C function also minimizes code size and minimizes code redundancy. Functions provide abstraction. For example, printf is a function given by standard library code. So you need not to worry about how it is implemented and it serves your purpose, right? So in your program, if you want to perform the same set of tasks again and again, then create a function to do that task and call it every time you need to perform that task. So the main aim of using function is to reduce the code redundancy in the program, and it brings more modularity to your program and also decreases the final executable size of your program. So this is a general form of a function definition in C. So when you write a function, you first have to give a name for the function, a proper name. So you can follow the same rules what you use to write a variable name. And the function always comes with parentheses. And inside the parentheses, you have to mention the parameter list. So these are the input parameters or input arguments to the function. And also you may mention the return data type, that is the data type of the data which the function returns. So a function may return a value or it may not return a value. So we'll see more about this as we make a progress. So this is called as a function prototype. So a function prototype says its return type, the function's name, and its parameter list. And after that, you have to use these curly brackets, which actually gives the body of the function. And inside the body of the function, you have to write your executable C statements. Let's see one example. All right, so I'm ready with my new project. Let's say functions.c. So let's first write the main function. So main is also a function like any other function which has a function body, return type, the parameter list. So, but there are two ways you can define a main function in your program according to the standard. So let's explore them. So you can give main function definition in two ways. One is this one. This is a main function definition with no input arguments. Here you can see that there are no input arguments. So when there are no input arguments, you can mention it as void, or you can just leave like this with just a parenthesis, no problem. So this is another main function definition with two input arguments. So now these arguments also called as command line arguments. So we don't use this definition of main for embedded systems because most of the time there are no command line arguments in embedded system programming. So that's why we usually don't use this main function definition. So we usually use this. Let's write that. So, and when you write the main function, always make sure that the return type is int. That is, this function has to return an integer data by using return statement. Let's write return 0. Let's explore some more points about main. So main takes only 0 or 2 arguments. main function returns the status of the program to the parent process. So in this case, the parent process is actually the operating system, right? So because we are actually writing application for our Windows PC or our machine. So here there is the operating system, and operating system launches the application. So when the application ends, that application returns a code back to the OS. And by that, OS comes to know whether that process is terminated properly or not. So main function returns the status of the program to the parent process, showing the success or failure of the program. So 0 means success and non-zero means error. Alright, so now let's write a function to add two numbers. So now first let me give a function name. So let's call the function name as function add numbers. And after that, let's give the parenthesis and let's write here the argument list or parameter list. So let's say this function takes 3 input arguments. So let me call it as int A, int B, and int C. These are the 3 input parameters of the function add numbers. And let me decide that this function doesn't return anything. So no return value. So that's why in that case you have to mention the keyword void here. So void is the return type. So that means the function doesn't return anything. And after that, let's give the function body. So you have to open 2 curly brackets. So this is called as function definition. And after that, inside the function, you have to write the code to add 2 numbers or add 3 numbers. Let me create one more variable, sum. So sum is equal to A plus B plus C. So remember that this variable and these variables are same. So all these are local scope variables. So it is just that these are mentioned to receive the input values for the function. So these are also called as formal parameters, or you can just call them as local scope variables, no problem. And after that, let's print the sum. Sum is equal to %d/n, and let me print the sum. Right. So now whenever you want to add 3 numbers, just call this function. You can call it from main or you can call it from some other function. So that means this function is dedicated to add 3 numbers. Let's see how to call this function. So let's say I want to call this function from main. So I go to the main and I write the function name, and then I open the parenthesis, and after that you have to give semicolon. So this is function calling, and here you have to pass the arguments to the function. So this function takes 3 input values of type int. So you have to do according to that. So you have to pass 3 integer values when you call this function. So let's use 3 integer values. Let's say 12, 13, 14. I can call this function one more time. So I can mention -20 plus 20, 14. And after that, you can even pass variables as arguments. Let's say you have int value A is equal to 90, and let's say value B is equal to 70. You can even do something like this. So you can pass value A, value B, and third argument you can pass anything you want. So let's say 90. So this is also a legal statement. So it can be combination of a number and variables. And after that, so now let's see how it goes. Let me try to compile. So I tried to compile this and there are various warnings, and now let's try to understand one by one. The first warning is implicit declaration of function add numbers. So that means for the compiler, before calling a function, you have to declare that. In the same way, what you did for variables. So before using a variable, you have to define a variable, or at least you have to declare a variable that it is exists somewhere, right? So same rule you have to follow for functions as well. Before using that function, you have to declare to the compiler that it exists somewhere. And we do that by using something called function declaration, or it is also called as function prototyping. Let's explore about function prototyping or function declaration. So now let's explore about function prototype. So in C, functions first have to be declared before they are used. Prototype lets the compiler to know about the return data type, argument list, and their data type and order of arguments being passed to the function. So if you just observe the error here, so what it is saying that implicit declaration of function. What does that mean? So basically compiler is saying that, so here I encountered an usage of user defined function, but its prototype is not found. So that's why compiler is assuming the prototype. So it is assuming something else. And after that, compiler proceeds. After that, it comes to the real function definition, which is implemented right here. And here, compiler comes to know about the actual prototype. And that's why the second warning, conflicting types. There is a conflict between what it has assumed here and what it has found here. So this you can leave. And after that, it is saying again, implicit declaration of function printf, because we have used printf here, but we didn't tell the prototype of that. And we do that by using hash include, right? Because printf is not written by us, right? So it is written by standard library code. So that's why we have to give standard library header file in order to include the prototype. And after that, we have to mention the prototype of this function before you call that function. So that's why what you have to do is you have to just copy this line and go to the global scope and just paste that line and give the semicolon. Right, so now before calling the function, compiler will encounter the prototype. So you need not to mention int a, int b, int c. You can even mention just int. So that is also fine. But what we usually do is we just copy this and paste here and give the semicolon. And now let's try to compile. No warnings. And after that, since it is a void function, you need not to mention any return value here in this function. When this function is called, so the value 12 will be copied into int A, 13 will be copied into B, 14 will be copied into C, like that. So, and the number of arguments here should match number of arguments what you pass here. So otherwise it will be a problem. For example, if I just pass 2 arguments here, then compiler will not let you to proceed. So that's an error. It is saying that too few arguments to function. Right, so let me give number here and let me try to compile and let's execute. So I hope you understood about writing a simple function definition. And in the next lecture, let's see how to return a value from a function. And I'll see you in the next lecture. Hey, welcome back to the lecture. Now let's modify this function to return a value to the caller. So in this case, main is the caller. This is the callee. So I'm going to remove this printf from here. So let me cut that code and let me remove all these codes. Let me just keep only one function call. And here, let me use this function to just compute the sum and return the sum back to the caller. I'm not going to print that here. So I'm just computing the sum and then I'm returning that sum back to the caller. So when the program execution control comes over here, that is the value which is stored in the sum will be returned back to the caller and the control goes back to the caller. So here you are returning a data or value of integer type, right? So that's why the return data type has to be int now. So just mention int over here. Very simple, right? So after that, the value will be returned back to the caller, right? So that's why you have to catch that return value here, a value which is returned from the function. So for that, let me create a variable, let's say int return value. Let me catch that here. Return value is equal to function add number. So when this function is called, a sum will be computed and sum will be returned, and that return value will be stored in this variable. And after that, let me print the return value here. Sum is equal to %d/n return value. We also have to change the prototype. It is now int, right? Let's try to compile. and the build is fine, right? So you get the same output. So that's about returning a value. So here, the value which is returned from this function is copied into the int variable of main function. So you can return int type, long int, char type, pointer type. So all those data types you can use as a return data type. Welcome back to the lecture. So in this lecture, let's do one exercise. So write a program to do mathematical operations such as addition, subtraction, multiplication, and division of integers. So you have to follow these two steps. One, do all the mathematical operations in a separate functions in a file called math.c and call the functions from the main.c to test them. So basically, your project should contain two source files. One is math.c. Let's say it is written by you. And inside the math.c, you have to write functions to do the mathematical operations. And let's say there is one more source file called main.c. Let's say it is written by someone else. And main.c uses functions of math.c. So here you can use the concept of header file. So you write all the function definitions in the math.c and you write all the function prototypes in a file called math.h and then share that math.h with main.c. So the main.c will come to know what are all the functions supported by math.c by looking at its prototype. So I just created a project called math, and after that let's add two source files. So first let's create one source file and I would call this as main.c. And let me add another source file. Let's call it as math.c. Let me finish. So this is excluded from the project, so I don't know why. Don't worry. So for you, it may not be like this. Let me just go to the properties and uncheck this. Go to the C and C++ build and uncheck this option. Apply, apply and close. So in the main.c, we are going to write all the functions for our arithmetic operations. Before writing functions, let's first create the function prototypes. So let's give the name first. So let me call it as math add. This is a function name. And after that, let me give the parenthesis here. And here, let's write the input arguments. So this function takes two arguments. So it is used to add two numbers of integer type. So int, let me call it as n1 and int n2. Let's say it returns a result back to the caller, isn't it? So the type of the return value, so let's consider it as int. And now let's terminate the function prototype. So this is the first function prototype. Let's create other functions. Let me copy and paste. So let me call it as sub, mul, and div. And for the subtraction, also I would like to use the same prototype. And after that, multiplication. So here, n1 will be multiplied to n2. So the result may exceed int range. So that's why let me use here long int. The return type I would like to use long int. The math division, so here n1 will be divided by n2 and the result may be float, isn't it? So two integer divisions can result in float, right? But in C, what happens is integer divisions result in integers. So they will not result in float, but we'll see how to convert that into float. So this is my function prototypes and let's implement. Let's implement all these functions. So that's what we call as function definition. Again, copy and paste here and just give the function body. So let's not keep this function prototypes inside math.c. So now let's create one more file called math.h. So let's create that. Header file. So here select default C header template and give the name math.h. So once you create the header file, you can see that this IDE is automatically adding these macros. So these are called as include guards. So you should make sure that your header file contains this include guards. So if the header file doesn't contain this include guards, then you should write this include guards manually. So here this is called as a pre-processing or preprocessor directive of the C compiler. And this can be any value. So it can be set of any characters. So it actually avoids multiple inclusion of the contents of the same header file in a project. So now we are going to keep our function prototypes between these statements. So let's cut this code from here and let's put that in math.h. So these are also called as exposed function prototypes because the main.c can include this and it will come to know about the function prototypes of math.c functions, right? So now let's implement the functions. So here let me just return n1 plus n2. So only one line of code. So here let me return n1 minus n2. Alright, so now let's return here n1 multiplied by n2. So to multiply you have to use asterisk. So this is actually results in integer value, right? So because n1 is an integer and n2 is an integer, and if you multiply those two numbers it will result in integer. Let's move on to the math division. So here let me just want to do n1 divided by n2. And this is also integer division. So here we are dividing two integers, right? So the result will be an integer. It will not be a float value. So later we'll see how to fix this. So now our math.c is completed. So now let's go to main.c. So main.c is empty. So first let's write the main function. And after that, first let's include the math.h because we are going to use those functions, right, which are implemented in math.c. So let's include math.h. So this is how you include a user-defined header file. So this is written by the user, right? So this is not given by the standard library. So that's why I have to include like this. So I have to mention the name between the double quotes. So you cannot use this. So you cannot do something like this. This is wrong, right? So all the user-defined header files must be within two double quotes. And let me include standard library header file. And after that, let's use those functions. So let me printf add. Let me print the result of adding two numbers, %d, right? And here in the printf, I can directly call that function. So you can directly call this function, let's say math add. Right here, math add. So you have to call this function with two numbers. Let me write the first number in hex, a 4-byte value. Let's say 0FFF1111. So this is a 4-byte value, right? And this is a positive value because the most significant bit is 0, right? That's why this is a positive value. And after that, let me add another number in hex. So let me keep the same number. So here, this is a function call. Note that you need not to terminate this function call with a semicolon here. It is not required because this is a complete C statement and a C statement is terminated by a semicolon. And the math add actually returns the result, right? So that result will be printed with a format specifier %d. So now let's run. Let's see what happens. Here it is. So this is the result. So now let me verify with the calculator. So I have a calculator here. First, let me write 0FFF1111, which happens to be this number in decimal, and this happens to be this number in binary. So plus FFF1111. So which happens to be 536748578. So this is a hex format. So if you want to print that in hex format, use X here. So that seems to be correct, right? After that, let's call multiplication on the same number. Let's see what happens. So the multiplication of these two numbers will result in a bigger number, right? So it will be of size 8 bytes maybe. Let's first try in calculator. So let's see what happens. So let me copy this number and let's say whether it takes or not. mistakes, no problem. Multiplied by the same number, which results in a very big number, right? So this is a decimal equivalent. This is a hex equivalent. And you can see that. So this is actually of 8 bytes, right? Long int type. So now let's see whether our code prints the correct answer or not. So this must be the correct answer. Let's see what happens here. So by the way, we are printing 64-bit value, right? That is 8 bytes value, because this actually returns, oh, sorry for that. So I have to use multiplication here. So this function actually returns long int, right? So that's why I have to use the format specifier long int. So that is I64X. And now let's see how it goes. Let me run. So now you can see that the multiplication result is wrong, right? So it just printed the last 4 bytes. And the upper 4 bytes are actually discarded. So that means there is an information loss, right? The reason for that is, if you just take a look into this function, so here we do integer multiplication, right? So integer multiplied with integer results in integer. So now in order to solve this problem, so what you have to do is you have to consider one among these number as long int. That means you have to typecast one of the variable. About typecasting we'll see later, but let's use the typecasting in order to solve this issue here. So let's change the type of this number to long int. So that we can do by casting. So in order to do casting, in front of the variable name, open the parenthesis and mention the data type name to which you want to cast. So let's do that. So here I am casting. This is a casting to this variable. Now I'm changing the type of this variable to long int. So now a long int variable multiplied with int results in long int. So now it should be good, and more on typecasting we'll explore in the later lectures. So there are 2 types of casting actually, or typecasting. One is explicit casting and another one is implicit casting. And this is what we call as explicit casting. That is, you are manually doing that. So after that, now here also we have to cast, because integer divided by integer results in integer. So here also you have to consider this number as float. So one of the number as float. Let's try once again. So now let me just print up. Let's also test the division. And the format specifier is %f for float. And let's divide 100 by 8. So now let's run the program. And here you can see that we actually get the correct answer, right? Now the answer is correct. That's about this program, and I would suggest you to reproduce this application at your desk in the next lecture. So I'll be covering typecasting. Welcome back to the lecture. So in this lecture, let's learn about typecasting. So what is typecasting? So typecasting is a way of converting a variable or data from one data type to another data type. And the data will be truncated when the higher data type is converted into lower data type. So now let's move forward. So there are 2 types of casting. One is implicit casting and another one is explicit casting. So implicit casting is also called as assumed casting. So because compiler does this. So compiler will automatically cast some values or some data or some variables automatically according to compiler's default rules. And another one is explicit casting. So if you want to override what compiler does or what compiler assumes, you can use explicit casting. So explicit casting is, as its name indicates, it is telling the casting explicitly through your code. So that's why it is done by the programmer. Let's understand these 2 types of casting using an example. So here I have a code snippet, and here, so let's understand the first C statement. So this is actually a variable definition and initialization, right? So here, the data type of this variable is unsigned char. So that is actually at the left-hand side. And at the right-hand side of the assignment operator here, so there are two constants, right? So what is the memory size of this number? That is not written here, right? You have just written a number, right? So this is actually a 1 byte data, right? So which is written in hex format. 0x87 is a 1 byte data. That is true for you, so, but for the compiler, it is 4 byte data. So this will be treated as a 4 byte data. That's the default data type used for a constant by the compiler. So, and this is a 2 byte data for you, but for the compiler, it is again a 4 byte data. So if you don't mention any data type for this constant, then it is considered as an int type. That's a default type. So if I try to compile this code, here it is. There is a warning from the compiler saying unsigned conversion from int to, this is an int. The value is of int type. And you are trying to take that int type and trying to put that into a variable of char type, right? Or unsigned char type. So you are trying to fit 4 byte data into a 1 byte variable, right? And that's why there is a warning saying the unsigned conversion from int to unsigned char changes the value from this one to this one. So that is actually an information loss. So what compiler does is it actually truncates this int to 1 byte data, and then it stores that data into this variable. So compiler is warning you that it actually did the implicit casting, and in that process it finds that there is actually an information loss. So what if I convert this into 0, 1 and let's say 0089? Let's see what happens to this statement. Here you can see that there is no warning. Here also compiler is trying to put 4 byte of data into 1 byte variable, right? So but there is no information loss here. So result will be 0 cross 8a, right? In this case. So 8a can be stored into data, right? So hence there is no information loss. So that's why compiler is not warning you in this case. So compiler actually sees this statement like this, and after that it truncates or casts this 4 byte data into 1 byte data, and then it stores in this variable. So that actually involves implicit casting. Alright, so now if you want to avoid this warning, or if you want to resolve this warning, then you have to use explicit casting here. That means you have to tell the compiler explicitly that just store 1 byte of the result into the destination variable. For that, you can use explicit casting here. So what I would do is I'll put these two numbers and the plus operator in this parenthesis. And after that, what I do is I actually cast the result to unsigned char. So this yields one result, right? So that is of type int, and I'm casting that to char explicitly by using this explicit casting. This is called as explicit casting. So it will not generate any warnings here because the programmer is aware of what he's doing, right? So there is no warning for that. This is what we call as explicit casting. All right, now let's see what's happening here. So you have a variable called result of float type, right? So you have declared that variable as float because you want to store a real number, right? See what's happening here. So when the result is printed, so 80 divided by 3 should result in fraction part, right? So that fraction part is omitted, right? So that means there is an information loss, correct? So the fraction part is lost. So what's happening here? So first of all, compiler sees this as an integer, right? So integer divided by another integer, that will give you another integer, right? So integer divided by integer remains integer. So that's why the fraction part is lost. After that, you are storing the result. That's why only integer part is getting displayed. Now, in order to solve this, you have to tell the compiler to consider this number as a float or this number as a float, not as an int. And here you have to do explicit casting. So let me do the explicit casting to the numerator. Let me call it as float. Here I have converted the data type of this number from int to float. Compiler will consider this as float. So a float divided by another float. So here numerator is float. So hence compiler treats denominator also as float implicitly. So it does implicit casting. So here basically what's happening is float divided by float, which results in a float. And now you are going to get the correct answer. Or you can move this casting to denominator, no problem. You can even do this. So here 3 is casted. So which also gives the same result. So I hope you understood about implicit casting and explicit casting. And remember that warnings related to casting is very dangerous because most of the time you will lose information, right? So that's why those warnings should be treated with utmost care. And as I said in the beginning of this course, warnings are always dangerous and you should always try to resolve those warnings. So with that note, I would like to end this lecture and I'll see you in the next lecture. All right, so now let's continue our discussion about casting. So here in this code, I would like to include some other data, some different data. So this time, let me use 6-byte data. So let me write the 6-byte data. So I'll write it in hex. Let's say 1F, FF, FFFFA0. So this is a 5-byte data, right? Let's say B0. So this is actually a 6-byte data. So now let me add a 2-byte data to this. Let's say 1, 2, 4, 5. So this is a 6-byte data and this is a 2-byte data, right? So 6-byte data cannot be represented by int data type, right? Compiler will consider this number as long int, not as int. And compiler treats this number also as a long int data. So that means there is an implicit casting on this number to upgrade its data type from int to long int. This is actually addition of a long int with another long int. Let's see what happens when you try to compile this code and there is a warning saying you are trying to store a long int data to a variable whose type is char, and it is warning you about the data loss. All right, so with that note, I would like to end the discussion on typecasting, and we are going to encounter typecasting again when we cover pointers. And it is very important when dealing with pointers.